Hello and welcome to part 10 of the UBIK solution. I think this video, if I recall correct, is about how to start to add in the elbow, which is also referred to as the lower arm in the part of paper. And for that, we're also going to need to look at the cosine rule. So actually, let's begin out with that. And we need to make a little drawing. And actually, if you are wondering where I put these drawings, it's in the resources file here. There's a small file here called small stickman scribble. It is this drawing that I keep updating. So if we look at the character here from above, then we have that other position here, the shoulder underneath, and then we have the upper arm left, and we have the upper arm right here. And let's say we have a hand left here, and we have a hand right here. And then the way we will create an elbow is by creating or figuring out where to put a point here that connects this. And for this part here, you can see there's a way smaller distance between them. So where do we put this elbow? Since the length between our upper arm and lower arm here, are fixed, that means that the logical place to put an elbow would be somewhere here and then here. If just for a moment we color this, we color this blue. So this is the lower arm, and here is also the lower arm. And we have also the, let's take a different color. This weird brownish color. Whoops. It's a bit difficult to do this. Awesome. That is gonna be this length here is the upper arm length. And so I'm just gonna do this for the left one. And that means that this is the lower arm length. And also the joint here is the lower arm itself. Whereas the upper arm joint is this one here. But as you can see, maybe, hopefully, this little stickman here represents, in a way, a triangle here. And that is where the cosine rule comes in. So if you Google cosine rule and you want to just generally know the math behind it, what I did was to Google cosine rule for angle, and the first picture here states it pretty clearly that the cosine of A is equal to the square of B plus square of A minus A squared divided by 2 times B times C. And you can see what these things refer to. So the small b, a, c, and so on, they refer to the sides, lengths, and the big one, a, is the angles themselves. So we convert that into something here. Let's pick a purple here. So then let's say this is the a, and this is the B, and then this is the C. Then this, the A side is here, the B side is here, and the C is the opposite here. And for this solution here, all we really need to create are going to be two angles really. It's going to be, let's see, just want to pick a color that is readable. It's going to be an angle here and an angle here. And this angle down here we're going to call for beta, and this is what we're going to call omega. So the formula for these two are going to be according to the cosine rule. So beta is going to be equals to, and because it's said, the formula is said, the cosine of A, in order to get the angle itself, we need to get the cosine inverse, I think it's called. But we're just going to write it like A cosine of, and then one of the sides here is going to be the C squared plus the other one adjacent squared minus, and the opposite side A squared divided by 2, and then it needs to be the two adjacent sides multiplied together times C times B. That is how beta is going to be, and similarly it's going to be for omega. I'm not going to write it out, but it's basically the same. So we're just going to translate this into a function, and then we're going to create these two angles here and then see how we can convert that into a working angle elbow. So just gonna move this out of the way. Where's my page here? So, actually one more thing. You might notice that this distance here we don't have at the moment, and this distance we don't have either. The only distance that we can generate is B here, because we can measure the distance between the upper arm and the hand itself. So we just need to figure out a way to generate or determine what the upper arm and lower arm will be. And for that we're just going to go into the calibrate function here and do a little assumption here. We are going to assume that the arm length, which is a full arm length from the hand to up to your physical shoulder, and if you look down your arm, you can see the elbow is situated more or less in the middle of the arm, unless you're kind of like an alien or something. Just to make it a little bit more interesting, what I'm going to do is to take this and multiply it by a fraction. So it's not exactly, I could multiply by 0.5, but I'm going to multiply it by a small off values, and you can also play around with this yourself by changing this value only 0.48. This, let's set this to the to be the lower arm length, and then we're going to take the arm length again and then multiply that by 1 minus 1, and then take this same little we just created here. So this becomes basically the remaining of up to 1. And then promote this to a variable, call this upper arm length. Okay, so now we have a way of determining, or we have a model for the upper arm length and lower arm length, and we can start to do the implementation. So the next thing I think we should do is to create a function for the cosine rule. We're going to use that in a moment when we go into the solve arms. The solve arms is this one here from the event tick here. Solve arms is currently empty. And what we want to do is to create two calls, one to solve the left arm and one to solve the right arm here. So let's call it solve elbow joint. So this is going to generate two things for us. Both, one thing is the lower arm and one is the upper arm. And it's going to take in one is the hand effector, and we're going to do this in shoulder space for now. I think this is the correct way of doing it. I'm not at this moment entirely sure it's the correct way to do it, but for now we're going to do it in shoulder space. And the other part we're going to use is the upper arm transform, also in shoulder space. So as you can see, I'm picking out the left transforms here. Actually, I think I'm gonna change them around so it's like this. Yeah. So we're going to solve elbow joint that we just created. Hello. Where did that go? Oh, right. My bad. Solve arms is calling solve elbow joint. Jesus. I must be getting tired here. So solve arms calls solve joint. Jesus Christ. Okay. So let's expand this a little bit so we can see what is happening over here. So it was going to take two parameters here to begin with. One is the upper arm, and the other one is the hand itself. And it's going to return two things for us. It's going to return a transform, and along with another transform. So one is the upper arm transform, and the other one is the lower arm transform. So for now, I'm not gonna bother moving this over because we're gonna need quite a bit of space for this. And if we just jump back in here, we might as well just connect this up here. And that means that the upper arm transform, geez, we have so many variables now. Upper arm transform in shoulder space, left upper arm transform. So this is going to be the left part here. So we're going to set that here. And eventually we're going to convert this into a world space again. And if you recall from one of the previous videos, we also did this in set left upper arm and right upper arm. We did it here. So actually what I'm going to do is, because it's no harm in doing it, except it's going to eat up a little bit of performance, but I'm just going to remove them from here for now, because we're just going to do this afterwards, and I don't think we use them in between here. So we're just going to do this. And well, let's just do it for the other one as well. What happened? Strange. Okay, never mind. So this one needs to be the right upper arm, in shoulder space, this one. And this one needs to be the right hand in shoulder space. Okay. So let's go and fire in a sequence. Okay, so now we have the basics here. The only thing we actually need to do also is to create this lower arm transform. Let's do it like this, and then add another reroute here, and then promote this to a variable, call this lower arm trans left, lower arm transform in shoulder space. And we're also going to need one in wall space. We're going to need one of each. So here we set it in shoulder space. That is what is being spit out here. And then we need to do this same transform that we do here. So convert that to create the left, the wall transform. And let's do the same down here for the right. Right, lower arm transform in shoulder space. And then do the conversion into wall space. Like this. So this is the structure of how solve arms will basically be. We may, there will be a small addition, I can tell, but let's for now go with this here. We also need to draw, or at least draw something. Yeah, well, let's just get back to that at the end. We can always address that in the end, yes. So solve arms basically done now, and all we need to do is fill out this stuff inside here. All right. The cosine rule, that's what I started out with. So let's go back to that. We need the cosine rule here. I don't know if there exists one, like just to take three sides and then spit out an angle. So I'm just going to make one. And here we want to return a float, which is going to be the angle. And as input, we're going to have three lengths. One is going to be adjacent side 1, adjacent side 2, and then the opposite side. And if you recall from the drawing here, so the one adjacent side and the other adjacent side added together, and then minus the opposite side divided by the product of 2C and B. So that's what we're going to do here. We're going to multiply this by itself. That's the most simple way of squaring it, I guess. So just going to copy this a few times. Like this. And like this. And then these two needs to be added together. And then we need to subtract this. And then finally what we need to do is to divide this by the product of multiply this side the two adjacent sides and also multiply them by 2. Like this. And this is going to give us a, we're going to say a cosine of this, so the inverse cosine. A cosine in degrees. Going to come out here and give us in an angle. All right, and I don't know if I mentioned it, but we are making this a pure function, so it's just a little bit more compact here. So inside the solved joint, elbow joint, we can now call it, and it looks like this. And we need to, let's do the beta first. So the beta is the upper arm length as one adjacent side, and the other one is the hand to length, shoulder or upper arm to hand distance. And that we actually don't have at the moment, so we're just gonna create that here first. So let's subtract them from each other and do a vector length. And let's dump this into a variable local. Upper arm to hand. Length. All right. So that is going to be the adjacent one side, and the other side here is going to be the upper arm length. So the upper arm length here, that's the one that we just created during the calibration part, and the opposite side is the lower arm length here. The blue part here, the lower arm length here. And that is basically what we need to get the beta angle here. Promote to a variable or beta. And then we also need to get the omega angle here. So that is going to be the lower arm length. Whoops. Lower arm length as the first parameter, and then the upper arm length as the second parameter, and then the opposite side is going to be the shoulder or the upper arm to hand length. So we just need to switch things around a little bit. So we set the upper arm length and or the lower arm length, the upper arm length, and then the upper arm to hand length. Yes. Oops. And let's call this omega. Okay. So that's the angles that we need to create the basis for the elbow. So let's switch back to the drawing just for a moment. So in order to get a rotation or a rotation plane reference, let's call it that, we need something to start out from, and what we're going to use here is going to be this here, the red one, going from the upper arm to the hand. And what the beta does is to rotate it out here and along this length here, then we get this point here. And then from this, having this point, we can then figure out what we want to need to do, rotate to get to the hand. That is the second part. So we have the upper arm hand and arm to hand direction here. We could use that, but we're going to, well, actually we can't use that. That's kind of the problem. But we can use the positions instead. So upper arm, get the upper arm and get the hand. And then we can do a find look at rotation. And this is going to have to do for now, unless we want to dive into either some pretty cryptic math, or we want to do some C++ at this point here. If I can figure it out, I will definitely switch this out at some point. So for now, we just have to live with this one, and live with, by that I mean this function here, find look at rotation, is based on this make rotator from X, which has a singularity if you have these two directly above each other. So it has a singularity on the C-axis. So just be aware of that. That means that this is not perfect, and definitely not the best way, candidate to use for creating this. Anyway, so let's continue. It does work. Just wanted to mention that it does work, but it's not the best way. We need to combine this rotator that we have now with some with that rotator that we just created, and that rotator we can make by making use of a make rotator from axis and angle, which is another handy function. And the axis that we're going to use, if you kind of imagine that you have your shoulder out here, the upper arm here, it is pointing upwards here. So when you move your hand around that plane, this is a good rotation axis. So when you have your hand straight down, this is actually pointing a bit forward and so on. And if it's outward, it's pointing somewhere up and back. I hope that made just a little bit sense. Okay, so anyway, get up vector. What happened? Get up vector. And we're going to feed that in as the axis, and then the angle is going to be the beta angle that we just calculated here. Again, referring to the drawing here, it's this angle that we are setting now, so we are making sure that we get out here. And that means that we now have the final rotation to return. So actually we can grab this one over here, the return node, make transform, and say this is going to be the rotation. There's nothing more really to this part here. Okay, and the location, we already have that. That's the same location that we just fed in, so it's going to be the upper arm here, and that's basically it. So for the lower arm, it's a bit different story, because we need to take. It's a bit difficult to explain otherwise unless I use the drawing here. The way we want to place the rotation here, the omega rotation here, is by rotating this in the upper arm space. So since we now have an upper arm transform, this one, we want to create take this omega that we have just calculated, and use that to put this omega angle here in the space of the upper arm. It will make sense, hopefully. Otherwise, don't worry. It took me a while to figure this part out. So when you compose, again, remember the reference transform needs to be at the bottom here. So order matters here, and then make a transform here. And whatever comes out of this is going to be our lower arm. So we can connect now all this stuff up here. like this. All right, so the rotation, well, the rotation, since we are doing this in the upper arm space, it just needs to be in the yaw. So that omega that we just calculated is just going to be yaw like this. And if we now, let's see what happens if we hit play. Right. We get something. Do we get something at all? No, we don't actually. Let's see, what are we missing? The upper arm goes to the upper arm here. Left upper arm to weld. Left oh, this one. Notice that I forgot to substitute the set left upper arm and set left upper arm in wall space, these two. I forgot to switch them out. So, as some clever person once told me, overuse of paste and copy makes the programmer sloppy. So, let's fix that real quick. Okay, so now we have the hand, and you can see actually now the shoulder is actually looking, or the upper arm is looking at the hand, or it does something, and we are not visualizing the lower arm yet. So let's do that in the debug draw here, just towards the end, really. Draw an axis. Let's take this one because it has the right color. Draw an axis, and let's say the left lower arm transform in shoulder wall space. This. Let's see where it lands. Okay, so right now it's not. You actually see something if you watch closely. You can see 2 points are in this place here, and you can see that because there are two red arrows, 2 forward arrows, axes. So we have 2 points in the middle here. So we actually forgot to do one thing. We forgot to move the this joint here, and we need to move it along, since we're in the space of the upper arm. We need to move this along the forward direction. So we can type in vector forward, and then multiply this by float, and that needs to be the upper arm length, and like this. I hope that made sense. Otherwise you can view it like this. The point was here, and we are since the transform that I'm editing, that has been converted into upper arm space. So since it's pointing towards this point now, adding the upper arm length in the forward direction is going to move that point down here. So when we then get that point out here and into the lower arm transform, that is going to be where the upper arm ends. So now we get a new transform out here, and we can see it's starting to move somewhat here. So let's draw one more line here, actually let's draw 2 more debug lines here. We have one here. So I'm only going to do the left one first here. The shoulder transform. So this is the left upper arm transform, and we need the left lower transform, and in wall space. And yeah, you know what? We're also gonna do the lower arm, but this is gonna maybe look a little bit weird. So the second line we're drawing here is gonna go from the left lower arm to it, and we could just take it and move it to the hand, but it is not necessarily always able to reach it. So what we're going to do instead is to take this and add a vector, and we're going to add in the lower arm length, and then take the lower arm transform, multiply that by a get the forward vector, and then multiply this by the float. This should technically give us the same, or in most situations, the same location as the hand is in, if we did our math correct. Which I can actually already tell you it's not, but anyway. So let's just do it for now. So no, it ended up in a weird place, I think, somewhere like very far away. Oh, I multiplied this. Okay, so plus, I meant plus. Jeez. Okay, so anyway, it's still wrong, as you can see, because the hand is out here. But you can see something is moving around here. So the math here is a little bit off. So to begin with, this joint here is pointing towards it's pointing inwards, and we want it basically to, if we look at our own shoulder, we want it to be pointing outwards. We don't want the opposite, it to be pointing inwards as a base rotation. That's the most unnatural way to have it. So let's inverse that a little bit here, and we do that by going to our solve elbow thingy here. So we need to add in another component into the solve elbow joint, and that needs to be a parameter called is a left hand, which we're gonna now use to take this this angle. So this omega angle, if we look at what is happening, the omega is this angle here. Actually, let's take the other one first. Let's take the beta first. So the beta is this one here. So when I move closer, you can see it gets smaller. This angle gets smaller, and when I move it out, it gets bigger. So this is this should have been over here instead. So what I'm thinking is that we need to take this and, if I'm not mistaken, do a select float here, and then say if is left hand, and then if it's left hand, we multiply this by -1, and otherwise by 1, and times float, and like so. That didn't change anything. Oh, we also need to change this one. So inside solve arms, make sure to set a check mark in this one. Otherwise, nothing is obviously going to happen. And now you can see it's actually moving. And when I stretch my arm out, it's, instead of stretching out the lower arm, it's actually collapsing on itself. So we need to invert, or not invert, but say 180 degrees, take the omega here, do something almost similar, but then again it's not. So depending on whether or not this is the left or the right arm, we're gonna say this omega angle that we have, we're gonna say minus, and we're gonna say plus. So if it's the left hand, we're gonna say 180 minus that angle, and if it's the right arm, we're gonna say 180 plus. Can I clean this up a little bit? All right, I think that's pretty enough. So now you can see it's actually hitting that point here. And as you can see, once I keep moving the hand away, it can't reach it anymore, but you can see where it ends here. So this is also a good way to visualize if it's able to reach. What Matthias Paget did in his thesis project here was to take and allow the upper arm to dislocate, so he would allow this actually to move in the direction of the hand. I haven't done that, and on the other hand, I haven't found a way to do this, which I'm happy about. So for now, you will have to live with this solution, and just bear with me that I don't have a proper solution for this at the moment. But for now, I think it's okay. As you can see, the right arm, it's not being set at the moment, but I suppose that you can figure this part out yourself, and otherwise, since we are actually setting everything, we can just finish off with that. It's just the last three debug statements that we did here. Just take that real quick, and we can do one final test, and then that is it. So this needs to be the right lower arm in wall space, the right lower arm in right lower arm in wall space, and the right upper arm in wall space, and the right lower arm in wall space. So we need to move this one up and this one up. I think that's it. We just need to change the color. This one needs to be green. This one needs to be green, dark green. And the same for this one. Okay. Nope, not okay. Oh, clearly not. What did I miss? Right upper arm. Right upper arm. Right lower arm. Right lower arm. Right lower arm. right lower arm. Well, the good thing is I think the joint itself is correct. It's just let's see, this line here for some reason. So right upper arm in shoulder space, right hand in shoulder space. Gets right lower. Oh, this one is definitely wrong. This needs to be the right upper arm. Right upper arm in. And I realize I have to do something with the structure of this because I have so many variables now that I'm losing track of them myself. So, excuse me, I'm gonna do a little rearranging of these, I think, off video, and then I think I'm gonna just show them in the next video what I did. No? Right lower arm. Right lower arm. Right lower arm transform to the, what the heck, what is it, which one is missing? It's the one going to the it's the one going from the elbow to the hand, and the elbow to the hand should be this one. Right lower arm. Oh, fucking hell. Right lower arm in world space. Jeez. Yeah, definitely need to figure out some other way of doing this. It's a complete mess. Sorry. Now we have something working. Okay, let's do one last test in preview, and then we can move on to the next video in a short while. So yeah, this video definitely got a little longer than I was hoping for. So now you have something that actually is working sort of. The elbow is definitely not where it's supposed to be, but that's expected because we're not getting any of the rotation stuff, and it's not repositioning itself depending on where you have your hand relative to your shoulder. So that is something for next video, or yeah, we'll start off with it, I guess. All right, I hope you enjoyed, and I'll be seeing you next. Bye.